Chapter 7, Section 2, Probability Distribution. This section covers what a probability distribution is and what a normal distribution is. Knowledge of probability distribution and normal distribution is essential for understanding statistical hypothesis testing. Each possible value of a random variable occurs randomly, so we can assign probabilities of occurring to each value for a random variable. It is called a probability distribution. Specifically, probability distribution of a random variable x can be defined as a list of each possible value of x associated with each value's probability of occurring. For instance, the probability distribution of the outcome of throwing a six-sided die can be expressed in this way. Pips of a die is a discrete random variable. Probability distribution of a discrete random variable is called a discrete probability distribution. In general, a discrete probability distribution can be expressed in this way. Here, each value's probability of occurring must be between 0 and 1, and the sum of all the probabilities is 1. And a function fx that represents the probability that a random variable large X takes a value of small x is called a probability mass function. Probability distribution of a continuous random variable is called a continuous probability distribution. Body mass index, BMI, is an example of continuous variables. BMI is the body weight divided by the square of the body height. Both weight and height are continuous variables, so BMI is also a continuous variable. Let's consider a case. We have a large size of sample data, which consists of people with normal levels of BMI. Suppose the normal levels of BMI is 18.5 to 24.9. And suppose each BMI value has the same probability of occurring. So, what is the probability that the BMI of a person in this sample equals 24.0? For a continuous random variable, we cannot calculate the probability in the same way as we do for a discrete random variable. Because BMI can take infinite values such as 24.01, 24.001, 24.0001. These infinite numbers occur with the same probability. So, the value 24.0 is just a number in the infinite number of values with the same probability. So, its probability of occurring is 1 divided by infinity, so it is 0. Since in a continuous probability distribution, a value's probability of occurring is 0, for a continuous probability distribution, we use probability density instead of normal probability. Probability density represents the relative likelihood of occurring of each value within the range it takes. This graph visualizes a continuous probability distribution. The vertical axis represents a function of probability density. It is called a probability density function, PDF for short. The probability density cannot be negative, so the graph must be on or above the horizontal axis. A basic assumption of a probability is that the sum of probabilities of all events equals 1. So, the area under the curve and above the horizontal axis is always 1. Since the horizontal axis is a continuous variable, the probability of any particular value is 0. In a probability density function, the probability of any particular value is 0. So, a probability is calculated for an interval instead of a particular value. For example, to calculate the probability for the interval between A and B, we need to calculate the area of the region between the curve and the x-axis for the range between A and B. We can do it by the integral of the probability density function, setting the interval as A and B. In some cases, data has a symmetrical distribution, like these plots. In the left plot, the peak is the left of the center, and the tail is longer in the left, negative direction. Such distribution is called left-skewed. On the contrary, in the right plot, the peak is right of the center, and the tail is longer in the right, positive direction. Such distribution is called right-skewed. In left-skewed data, the mean is less than the median, and they are both less than the mode. In right-skewed data, the mean is the largest, and the mode is the smallest. Skewness is a metric that represents how asymmetric data distribution is. If the skewness is positive, the data is right-skewed, and if the skewness is negative, the data is left-skewed. Kurtosis is a measure of how pointed the distribution is from a normal distribution. It can be calculated by this formula. If a dataset has a high positive kurtosis value, it is sharp-pointed and no or only a few outliers. And if the kurtosis is negative and has a large absolute value, the data is heavy-tailed or has relatively many outliers. An extreme case of heavy-tailed data is a uniform distribution. To understand hypothesis testing, we need to understand normal distribution. Normal distribution is a type of continuous probability distribution for a random variable. A normal distribution is symmetrical on both sides of the mean, forming a bell-shaped curve. Normal distribution is the most frequently used probability distribution. It is because in statistical analysis, we often assume that the random variable follows a normal distribution when we do not know its actual distribution. This is a graph of normal distribution. The horizontal axis represents a random variable, and the vertical axis represents the probability density. Normal distribution forms a bell-shaped curve, so the data points around the mean are more frequent in occurrence than those far from the mean. Since data points are distributed symmetrically on both sides of the mean equals the median. And the peak of the bell-shaped curve is on the mean, so the mean equals the mode. That is, in a normal distribution, the values of mean, median, and mode are the same. And since data distribution is symmetrical, in a normal distribution, the value of skewness is 0. And a normal distribution's kurtosis equals 3.0. Another notable characteristic of a normal distribution is the empirical rule. The empirical rule can be applied to a dataset with a normal distribution. According to the empirical rule, if a dataset is normally distributed or approximately normally distributed, about 68% of the data fall within one standard deviation of the mean, and about 95% of data fall within 2 standard deviations of the mean, and about 99.7% of data fall within 3 standard deviations of the mean. So, this rule is also called as 68, 95, 99.7 rule. Thank you for watching. Please thumbs up and subscribe to my channel.